Hi, I'm Sean Tierney, and this video is the second group's second session of the 2019 workshops for Java and FRC. In this video, we continue building our robot repository by modifying the joystick code, implementing toggle controls, adding sensors, and introducing the concept of PID controllers. To work alongside this video, you need to have the following installed on your computer. 1. An active JDK, which you can get from the Oracle website. 2. Some version of Git. 3. A GitHub account. And 4. Visual Studio Code with the WPILib extension provided by FRC, along with the Java extension pack and the Git extension pack. The links for downloading these are down in the description below, and I hope this video is useful to you. Alright, let's get started. So we're gonna, we can start off modifying our latest code and we can make those buttons into toggles. So we'll go into how to do that. Okay, so to be clear, like a toggle just means like right when you press it, it changes the state, and then right after you've released it and then pressed it again, it'll change it back.
I'm not in the video call.
Not in the video call, okay. Oh, Caden, are you?
Yep, you're actually looking at my screen. And I'm looking at your screen. So it goes, woo.
Oh yeah, that makes sense. That's weird that I don't see a separate, whatever. Oh,
there we go. Nice.
Okay, great. So, can you go to Visual Studio Code and make sure you're on the master branch? Okay. Make sure you've pulled, and then once you've done that, you can make a new branch. If you want to do that in terminal, that's git checkout -b, and then the name of the branch. We'll call it, let's see, what are we doing? We're doing toggles, so we can just call it toggles. Or actually, well, what generally happens if there's multiple people is like one person would make the branch and the others would just kind of work on it, right? So, yeah, instead of everyone creating their own different branches. So, I'll make the branch, and I will push it, and so that way you can all here probably you'll want to like delete that one that you just made to avoid like name confusion, and then you can like check out to origin / toggles. Origin, that's the word I was looking for server. Yeah, that's the word they use. So I find it's easiest to just like go up into that terminal tab and hit new terminal.
Oh, you capitalize the T. That makes more sense. Nope. Can't switch to it.
Can't switch to it.
Did you push?
I did push.
Git. And you're on my repository?
Yeah.
Wait,
Am I?
I don't
Hold
think
on.
you are.
Yeah, you're right.
2019 FRC.
You know, you're right.
There's a bunch of
That makes a lot of sense.
branches that are still open here. Get rid of. Can we just like close these? Yeah, there.
Fake. Yep. Okay, now I'll make it. Yeah, I was wondering why there was nothing to pull. That makes a lot of sense. Okay, there we go. Okay, so I'll make my edit first. For my arm1, so once you're ready, you can look at my screen.
Wait, I can't seem to get onto the branch.
Good, check out. Oh, try origin / toggles.
Okay.
Get
forward
check
slash?
or get checkout.
Okay.
Yeah. / yeah.
Might work without doing that.
Yeah. Okay. You are on the right thing.
Did you pull?
Yeah, that's probably what it is.
Try get pull in there.
Yeah.
There you
There you
go.
All right.
Maybe I can get the branch from... Nope, I can't. Rip.
In the bottom left, you might be able to click on it.
Yeah, I tried. And
Get checkout.
Just try toggles.
yeah.
Oh, you said
There you
organ.
go.
You said
Oh.
organ. That's what it was.
Well, rip. Okay.
We got it anyway.
We're all good. There we go. Well, before I do this, do you have any ideas of how you would make a toggle?
You would have it so that you would have a boolean,
Yeah.
and when you press the button, it would just set it to the opposite of that boolean.
Isn't it like Boolean plus? There was a function
Boolean
for
plus
Booleans
plus?
to invert
Yes.
the Boolean. Yeah, I forgot what it was though.
Well, you could just say equals not.
Yeah.
Yeah.
All right.
I think the plus plus was when you put on the end of an integer.
Yeah,
to
you can do
add
that
one.
too, but there was Boolean.
In that case, how about we all just like do it for our own arm, like the same thing as last time. I'll be arm 1, your arm 2, and your arm 3. And we'll just not commit anything until we're ready.
So I need to make Is Boolean capital?
Nope. Only in Python. I think Python.
No.
No, it's not. I'm thinking of
It's not.
I'm thinking of true false or capital.
Yes. Yeah. And 3. Let's see.
Okay. All right, so so Caden, it kind of seems like, so you did 3, right?
Yes.
It kind of seems like your oh, if arm 3 spin state, if that left joystick got hit, get raw button, then you change that state. But that doesn't quite work because it doesn't. It wouldn't work because that teleop periodic is called every 20 milliseconds, and so when someone would hold that button down for more than 20 milliseconds, that would just keep.
Right.
It would just jitter. So you have to not ask it if it's pressed, but if it's pressed and it wasn't just pressed.
So how do you do that?
So that's like on my screen.
Where are you? You're
Yeah. So I have this arm1 button pressed. Do I ever initialize that? I do, right? Yeah, I do. It starts out as false, and then like when you press, so it's like whatever the trigger is at this point after it's done its processing. So that's it in the last rotation, in the last thingy rotation of the teleop periodic, and this is saying if it is pressed and that's different from what it was last time, or heck, I could even say if it is pressed and it wasn't just pressed last time, then you change its state.
Okay.
I also added this method to arm1 for clarity, along with an extender state variable. Ah, here he is. Here, I'll let him in. Have you met Edward?
Yeah.
Ah, okay, cool. That's it. Caden, wouldn't you be arm3 button pressed?
You're right. So that was like the.
Did you see any of the? Oh yeah, we need to invite you to the repository.
Well, didn't we already?
Maybe.
Just need to accept it.
I don't know.
I think we did. Yeah, we did.
Cool.
pretty much have just set down here.
So we probably wouldn't want a toggle for a rotator, right? Probably just want to hold it and then for when you want it, right?
Yeah. So where is no, that should just be a hold thing. Let's actually remove this completely and do so that we get raw written 3 and just remove this. And then I can remove is that being used anywhere? So, yep, I can remove it.
Cool.
That's probably good enough. Hopefully. Unless you see anything.
Let's
I tried to
see.
copy what you had.
R3 extender state. Okay, so if right joystick. By the way, your code from lines 125 through 129 just be replaced with arm3.setExtender, arm3 extender state.
Like
Mm.
this here? No, that's not 123. 123 to 125.
Or 125 to 129 can be replaced with just arm3.setExtender, arm3 extender state.
Well, yeah, that's what I was originally going to do, but then it didn't really matter. But
Yeah, it's just a little more efficient.
okay.
Fewer lines or whatever.
So we can delete the set right here.
Okay.
Well, you just don't need to make it a toggle. So, like, what you have right now is fine.
Okay. Yeah. Can I just use arm3.set extender 3 extender state? Do that. That can get rid of.
Yeah. Yeah, that works. As long as everything's initialized at the top.
Yeah, it is.
Cool. All right. Oh, right. I need to invite you to the call.
Use my screen guard as a server.
Ready for the invite? Okay. I sent it. I'll send it again then. I don't see you. Maybe it takes a second. So do you know how to clone it into, or
Yes, I have it up in Visual Studio.
cool. Okay, can you get onto, oh, well, we only have 3 arms to work on.
Copy and paste.
Yeah, copy paste. True. So can you make, or go on to the toggles branch? Okay, and then here, I think you can start. Actually, yeah, I'm going to commit. I'm going to commit these changes that I made. And then I'll push that. And then if you guys have your files saved, you should run a git stash in your terminal. Okay. And then once you have that, right. Once you have that, then you can lose your train of thought like I did. What was it doing? What are we doing? Oh, right. Pull. I did push, right?
Yes.
Yeah.
Mm-hmm.
And then once you have my stuff, like my toggle and all that, then you can apply stash. So in the terminal, you can say like git stash pop. Okay. And see. Errors, cool. So that's, so you can just make it so that they're both in there. Okay. And then once y'all have that, then, oh, well, you didn't need to do that yet, but then you can do your commit.
There we go.
Okay, and then you can push. And then once that's done, then you can pull and
So git pull. Already up to date.
Yeah, it's still okay. There, now it's done. Just finish
Alright.
pushing. Yeah.
Alright, please make your changes. So, let's dash in.
oh no, stash.
Oh. Then
Now pull.
it's pull.
Okay, and then you can get stash pop.
Where's Oops, what's that?
Cool.
What makes sense?
All right. Then once you've done that, then you can push.
Everything up to date.
Oh, did you commit?
No.
Ah.
What should I call this?
Call it ARM3 toggle.
There we go. Oh, I need to get add. That's AA. Add dot. Now we try again. Yay. Git push.
Okay.
Done.
All right. So now, Ethan, you can. Well, we should all poll at this point. Okay. And then, Ethan, once you've done that, you should like copy paste ARM1 into another class called ARM4, and it can be pretty much identical, just with a different name. And I know we could like just have 4 ARM objects coming out of one ARM class, but we already have 3 ARM classes, so I don't want one to just randomly be efficient. All right. And then you'll have to change the name of the class in the constructor. And then in robot.java, you can make an object that's just like the other arms. Huh. Well, there's only one. Okay. There's only one thing in robot init. I guess we'll fix that.
Ooh. It's just his.
Yeah. So we'll have 5 and 3 for the ports there. Could you also like fix our error and make sure there's an ARM1 and an ARM3 there? With ARM1 will be 2 and 4. I mean, no, ARM1 will be 4 and 2, and then ARM3 will be 6 and wait. I don't remember. No, I did right. 2 and 1, and then 4 and 2. There we go. So it's 2 and 1. I mean 2 and 0. Okay, and then down in teleop periodic, you can make an arm.
Ooh.
You can make like a toggle system that's similar to the others. You already know how to do toggles, right? So you're fine with just like copy pasting through it. Alright. Yeah. So then you'll have to make a separate ARM4 button pressed. So like instead of that ARM1 button pressed on line 168, and then make sure that is initialized up at the top. Okay. And last thing, there was it uses a set extender state, and yeah, and that method is in arm1.java, but not arm3.java. So easiest way would be to just recopy arm1 into arm4, since it has all the methods. So like that change in extender state was not in ARM3, which you copied over. As well as the method and how it uses extender state in the constructor and set extender. So I'm saying it'd probably be easiest just to like copy the whole class. All right, so once you save those and commit, then we'll be good. Are all your changes in robot saved? Okay. Yep. All right. So now, Ethan, do you want to do the honors of merging it into? We can just we can open a pull request and make sure that the changes are good. Here.
Close this.
I'll open the pull request then.
I'm gonna close this focus here.
Keep forgetting to make issues to go along with our things that we're doing and keep track. Oh well, it's not required. Alright, files changed. Okay, this all looks good. Alright, you think you want to merge it? Awesome. You can delete the branch too. We can also delete all our local branches that are called toggle. All right. And we can also pull our master branch. Okay. Okay. All right, so let's open a new issue, which is to copy some stuff from my robot, my last year's code that can be used in pretty much any year, and it's pretty useful. So I'm going to go there and do that. Okay. Oh, oops. There we go. Dang it. In fact, didn't want to do that. I should just go through Finder and it'd be a lot easier. Okay, that's the fake robot, and here is the real robot. Then in here, it was Miss 2019. There we go. And it should be in there. Cool. Huh. Are there... Oh, there are some errors. Here, let me just stash these. Come on. Am I on the right? Yeah. Alright, no local changes. Oh, right. I would need to... What does it mean, no local changes to save? Oh. Is it maybe because I... Here, wrong package name for all of it. I'll fix that. And it would be... Sorry, it's just taking a second, but... Alright. Fix that. Let me... Okay, I got it. It's because I have to add it all. Now stash. Cool. And I am pulled, and I can check out to a new branch, which is... Heck, I can even just... I will do a new branch to, what's it called? Okay, new branch there. And now I can stash pop. Okay. I will commit this now. There looks like they're duplicates, right? Oh, this stuff is in stuff is in bin. Weird. I don't know why I end up copying anything into bin. Okay. Well, copied Miss 2019. There we go. I got that. Now push. And now it's pushed, and I can talk about these branches. Okay. So, first off, there's enhanced joystick in here, which is a class we made to extend joystick and add a deadband. Have you ever heard of a deadband?
Nope, what is it done?
Well, it's basically on a joystick. If you are below a certain value off of the 0, then it will it'll read that as 0, and it'll scale everything else up from that minimum value. So that yeah. Oh, it did so. Yeah. And so we implemented that here. If you want to read the code, you can, but it just makes the joysticks a little less like sensitive in ways we don't want it to be. And there's also like really useful is a gamepad, since we as one of our things we have it as one of our controllers is an Xbox controller, and so we have these enums. Have you ever learned about enums? Little yeah. So an enum is basically so it's a class, but it defines its own objects. So here, like, it doesn't have a constructor in most cases. Here is an enum called axis, and it defines that it has these. It defines that it has these in this order. So there's like an enum method called ordinal. So like this has an left x has an ordinal of 0, left y ordinal of 1, and so on. And since get raw button basically, yeah, since get raw button uses them in a certain order, and this makes it so we don't have to know that order. All we have to do is say axis.leftx, and it automatically adds button.ordinal, so that we can use this get button instead of get raw button. Okay, get axis as button, basically just like how it reads, like if it's halfway pressed or more, then it's true. Has the same sort of thing for the buttons and the axis, for the get button and get axis, so we don't have to memorize anything. So yeah, if we didn't have this, we would just define the Xbox controller as a joystick, and we would have get axis for the and get buttons for everything, and just have to memorize all the values. But this makes it a lot easier. So once I go through and fix some small errors I'm seeing, this has been annoying me. Okay, there's that, and that's all of them. Cool. Let me pick small areas. Okay, good. Now, cool. So that's that enhanced joystick. Is there anything else I want to go through right now? Let's see. Abstract PID source, button toggle, expand extendable. Pad. Nope, that's all for now. So we should use that code to make ourselves a gamepad. How about we all do it, but only I will save it and commit it. Okay. That way we can assign some of these buttons to the gamepad instead of the joysticks. And I'll also have us use enhanced joystick. Is this spelled wrong?
Where can see?
No, that can't be it. And maybe it needs to be, oops, wrong button. Maybe it needs to be imported. Yeah, it does. Oh, right, it is in a different package, that makes sense. Since the package is default scope it uses for that sort of thing. Then we have a gamepad. Manipulator, I can call it. Okay. So you all can be doing this along with me.
I need to pull all that.
Mm-hmm. Oh, I should be charging my computer.
What do we have to change the package to? Just this 2019?
FRC dot Miss 2019. Everything's under Java.
And it's not the expected package FRC.robot.
Did you?
Are you supposed to make a new one?
Um,
Both the robot and this 2019?
Oh, did you? Wait a minute. Oh, I'm looking at the wrong. Let me look at you. Okay, so you are in there. You're in robot, so that should be robot because that's under your robot folder. It's only the Miss 2019 stuff.
Okay, so what do I have to change?
I don't think you, if you pulled everything.
It's still not finding it.
Did you? Here, can you make sure you import it?
Import.
Yeah.
There it is.
Yeah. Cool. And out. Huh? Huh. It was fine, and then I saved it. See that missed 2019. That's all fine. And this is weird. Let's. Yeah. Huh.
Gamepad's port 0.
Weird. Gamepad is port 2. Because it's also a joystick. What? Yeah. I don't know. It's not erroring on your screen, is it?
I don't have any errors.
Yeah. Why do I? Because I have it right, don't I? It's like it's only fine with it until I save it, right? Like that's weird. I guess I'll ignore it for now, and hopefully it'll sort itself out.
Usually the best solution.
Yeah. And
it's erroring all those too.
Well, that makes sense. So autocomplete might be out of the question for now. Yeah, none of you guys are here. Let me just
I've done everything
refresh
so
the project. Right? Okay. Yeah. Because if I delete this and save it, and then delete, and then, oops, keep doing that. And do that, and that's fine, and it's totally, if I save it now, it's really weird, just maybe, what if I just like that? It's over here. Yeah. I do hate to ignore it, but I guess I have to. Okay. I'll do that, and before it saves, I'll just do everything. Okay, so we can make the arm. Let's see, what do I want to set? We could keep the triggers maybe. We don't really have to use it. Like, you just have to remember. Like, I kind of like this control scheme already, with it just being on the joystick, so it's easy to test. And just being those two buttons and the triggers. So it's fine for now. We'll just move on. And I will commit this entirely red page.
Well, should we commit one of ours since it's not all red?
Yeah, yeah, that would be better.
Alright, let's see. This. Okay. Yep, commit. And a gamepad. And joystick. Not staged. Oh, I didn't even see that. Alright, try again. Done, now let's get push. good call.
Cool. Yeah, still red on my screen. Really weird. What if I'm gonna try restarting the Visual Studio Code. Yep, that worked. Cool. Alright, so now we're done with that. We can go to some inputs, some sensors and stuff. So we can start with an easy one. We can add some limit switches. Here, I'll make us, oh right, we need to merge that. What about that? Right. Here, you want to make it? Make sure you, if you haven't already done it, can you put closes number 9 in there?
Okay. Closes 9. So, close this.
Okay.
No conflicts.
Good to go.
Move. So it's
All right, so I'll make us a branch called called sensors. And it's pushed. You'll have to pull before you can see it.
switched.
You have to pull first.
I already did.
Maybe you didn't pull after I had published the branch.
Yeah, there it is. Instead of typing it out, you just press the up arrow and it'll give you previous commands.
Cool. And all right, Ethan, are you on input? Okay. Okay. So once we're all on it, we can each go to our respective branches, 1, 2, 3, 4, and make a limit switch for it. So the file name, or the class name for limit switch is direct input. And the .get method is what you use to read its value.
Direct input.
Isn't it?
What type direct input must be defined in its own file? It is what?
I think it's, let's use it, right? Oh, digital input. Okay. That's my bad, not direct input.
This was just a Boolean.
Yeah. Well, you all know what a limit switch actually is, right? Well, a limit switch is it's basically just like a switch that if you push it, returns on. If you don't, it returns off. The code can use that to make stuff like stop moving if it gets too close to a certain thing, and stuff like that. Because you modified the constructor and didn't modify its call.
So what's the channel be for that?
0.
420?
Amazing. Oh man, no it wouldn't. I mean, I guess we can engineer it to be. It would probably be 0, 1, 2, 3, like for each arm. But we can make it 1, 2, 0, 3. Let's do that. Yeah. Okay. Let's see. How could we how about like if it's pressed, you probably want it to stop moving. To like stop the rotator from moving. So for each arm, yeah, we can say, yeah, we can include that in the if statement. Okay. Okay. So when you're using GitHub, you should like try to just have as much as possible that if you do one thing, that's one commit. So in this case, like modifying arm1 would be like one commit, and using that in robot.java would be like a separate commit. It's not required. It's just good. It's good practice, so it's easily reversible and findable. Make sure you don't commit this stuff though, since we're all in the same branch.
Let's switch computers. Oh, yes.
Okay. Okay, I've committed and pushed mine. So, Edward, you can then commit and push yours. Oh, wait, make sure you've pulled first.
Okay.
So, you'll want to stash and then pull.
Stash. It's stash.
Conflict, okay. Okay.
So it's only the R2.
Okay. Oh, you have more, I guess.
Oh, I didn't save it, so I didn't see any result.
Ah.
Oh.
Yeah. And then you can, once he's done pushing, you can do your thing.
Done. So pull.
Oh, did you stash?
Yes.
Yeah.
Okay. I'm going to git merge. Not merge. Commit. yeah, get add done again. What? Oh, I need to get stash conflict.
It's probably the same area, right? Yep.
Yep. Okay. So what should be happening here? So incoming changes.
Right.
So should I just accept incoming change?
Yeah, you can do that and then make sure your arm 3 is
Yeah. Arm 3 422. That is correct.
420.
420.
Oh, what?
This is gone.
Yeah, what?
Okay.
What happened? I thought that would keep the third parameter for
Can I
arm.
undo? Yes.
Yeah, you can.
Okay.
Except incoming change. Oh, incoming change is your stash pop. Okay, so.
Okay. So it's probably accept current change.
Yeah.
Okay. 201312. So 3
0.
0. Okay. That's 30.
Just so that we can have 420.
Yeah. All right. Save. This one's red. Constructor arm 1 is undefined.
Um.
Do we have something else?
Can you look in arm1.java? It looks very defined.
Yes,
It's saved, so.
This is saved. Just do it anyway.
Press go and refresh your project. So, yeah.
Just says refresh explorer.
Should still, or just right click on,
Okay.
yeah. There should be like refresh project or something like that. Like around.
I don't see the refresh project. What was it? Was like Control Shift P to get the thing? Okay, refresh. Refresh Explorer. Refresh any projects, or just refresh projects.
Yeah, you can do that. And if that doesn't, try just exiting out and coming back in. Let's see. It's getting the right arm 1. Yeah.
Oh.
Oh.
Got the overview.
Yeah. But
None of that. Another one. Here we go.
cool.
All right, that looks good. So where was I? So pop. Now we did commit.
Yep.
Skip this. Make sure we can skip git. Add that. Commit. Dash m. Arm 3. Switch. All right. No conflicts. Git push.
I think there has to be some way to like set it.
Okay.
I'm sure I've like done it already, so that's why I. Though it's not asking you for your username or and whatever.
It's own username. Maybe does he have GitHub Desktop installed? I don't think so.
All right. Well, now that you've done that, pushed. Now you can do yours. So you can do your git stash. And then your git. Then your git first git pull. Okay, and I guess, are there... can you check in robot.java? I'm surprised that there's... I'm surprised that there's no conflicts. Right. And go up the to the robot init. There it is. There are conflicts. Oh yeah, it does say conflict. There we are. Yeah. Okay. So you can keep your 5.3. Should be 5.3.0 instead of 5.3.1. Oh, you are. Never mind. What was it? It should be 5.3.3 then.
Would you accept current change before you change the stuff?
Yeah, that would make sense. Accept current change and then you can do 5.3.3. Yep. All right, and then you can merge it. I mean,
Save.
Yeah, save and then commit. No, I'm saying merge instead of commit.
Yay.
Cool.
No. Push.
Yep.
Pull.
All right. So we want to open the pull request this time.
Who hasn't? I don't think Edward has.
Okay.
Okay. Do we open the issue? No. Let's scroll. Just scroll to the next slide.
Should have done the closes.
We didn't have a.
Oh, we didn't?
No.
Oh, well, never mind then.
Okay. Merge pull request.
Oh, wait. Let's just look it over first.
The master must give his approval.
In files changed.
And my thing's getting mad at ARM4 now. It was changed since we started this.
Yeah.
Okay.
Mhm. Oh, yeah, there are some issues. There's an ARM4 imported lowercase limit switch, and there's no limit switch port as a Here, I'll just fix these. Final, all that. Oh right, it's not limit switch, it's digital input. Okay. And that's good there. And then in robot, there's get limit switch, parentheses, and that should be it. Oh, and we need to say and not ARM4 so that it only moves if the limit switch isn't pressed.
Don't we usually set the limit switches up so that way the power is reversed? That way, if there's a wiring issue and it says the limit switch doesn't have power, that doesn't break the robot.
Oh yeah, we do. So that in that case, to make it clear, I think there's a set inverted method somewhere. Like, if we just were to say, here, we were to have another method set inverted in here, that would do the limit switch dot set. Is there not one? My thing is something else. Yeah, I don't think. That's too bad. Then yeah, we would have it in the class where we would return like not here, so that every time it's called correctly. So we'll just leave it as is. Okay. Leave it as is, and then here, I'm just gonna do, oops, wrong thing. Wasn't there a format? Yeah, Alt-Shift-S, that's what it is. That auto formats everything. All right, cool. I'll put that in there as get small errors. Okay, do that, and push. This is there. Then we should be good. All right, Edward, you want to merge it? Yep. We can delete our local branch too. So, by the way, a little interesting thing, git pull is, it tells it to run two commands in succession, git fetch and then git merge. So git fetch just gets the origin data and puts it somewhere, not sure where. Then you can git merge that. So if you want to do that step by step, you can. Just as a little interesting thing. Alright, so ready to move on to some encoders. Yeah. Have you heard of encoders?
No.
Alright, so encoders are these little, they're like these little magnetized things that go on axles to tell it like how far, like how much a motor is turned, and how fast it's turning. So we can use it as a sensor to measure distance and speed if we put it on a drive base, on drive motors. Or you can also use it to measure like the angle of an axle if you want to like rotate it. And we use it a lot for autonomous, and we also use it for some more advanced like things like PID controllers and stuff like that. So we'll imagine that this robot has stuff in drive base. Oh man, I named this input so that I forgot I named this input so we could put this stuff in there too. Well, oh well, just so that we don't have a messy branch history. and like have it merge the same branch, merge in there over and over. Also, it was deleted, so I'll make a new one. So I've always been making this. So Ethan, do you want to make the branch? So that's get checkout -b. Yeah, you would think it would be in get branch.
It
Like,
actually is. That's what I've been
oh,
doing.
really?
You just get branch in the name.
Yeah, it says.
oh. So get checkout -b just makes it and then checks that. So that's interesting.
And branch name is just like the encoders or.
Yeah. It works. Okay. And then you can push it. And then once you hit enter, it'll probably tell you you need to put dash. Oh, huh? What?
Do you need to
Oh, you.
check out first?
Yeah, that's it. You need to check out into encoders. So then you can copy that text, the git push dash dash whatever. So basically what that meant is there wasn't a branch in the origin that was called encoders for it to push to, so it just sets it up. Sets up the upstream origin. Okay. Okay, now we've got that. Here, we'll all do it, and only one of us will commit it. So, in drivebase.java. So this sort of thing where we all do a thing and only one of us does it. It's basically only happens here for teaching purposes. So we'll have the encoder as a field of drivebase.java. So we'll have two encoders, one for each side. Though we do only really need one. Normally we would have two, and we would have one set as a default, and then if it was like broken, we could switch it. So public, or no, we can make it private. Private final. Actually, is that the? I think it is encoder. Yeah. Left encoder.
Oh, you auto-completed it.
Yeah, I don't know why I did that. It's weird. Whoever does that for names.
That's the reason I would.
Well, yeah, exactly. Can't read your mind, except for right now, apparently.
It's just use much. Put it in as completed.
Yeah. Okay, so we can initialize them. Encoder. Okay, digital source A. So it has like 2 ports that it'll put in.
2 ports.
Yeah.
I think we're putting.
Oh, oops. Yeah, we'll take them in. Take them in as parameters. Okay. Okay.
What do these return?
They return doubles. Okay, I'm going to format it so that I can see the rest of that line.
Get.
Alright, so, just for my convenience, besides, like, there's a lot of things you have to do in order to set it up. I'm just gonna, like, copy the drive base code at this point. Where is it? Here we are, drive base. Oh crap, why did I copy that? That's silly. There we go. Okay, and now, it also has a gyro in here. Oh man, I copied the 1 year that we didn't use in coders. That's funny.
I already made bitters and setters, and that's like just bitters, but to set them up or something. Insert to complete block. Ah, I see that.
Okay, so in here, drive base. I'm just going to. Oh, yeah, this works. Alright.
Something happened.
What?
We missed pie time.
Oh no! For the first time in forever.
It's the end of an hour.
It is. That's sad. Well, maybe I'll get it at 341. Inverted pi time. Or anagram pi time. Or 431. I have a few chances. Let's see. So, in here, yeah, there's a PID output. Oh, PID controller. Oh no, this is all PID stuff. That's why it's so complicated. Yeah. Encoders. Yeah, I was thinking of all the PID stuff, that's all. The only thing we don't have is like the using left encoder and like switching between them and all that. Yeah, it's not bad. It's only the PID stuff that makes it complicated. So we have, for the sake of simplicity, let's just have one encoder. May as well. So we have public double get speed. I'll return the.
I'm just gonna keep both of them in there because there's no point deleting
Yeah. Return encoder dot get. What is that? Get rate, right? Isn't it? Yeah, get rate. We can have a public double get distance. Okay. There's a nice rename option in your right click for variables and methods. Oops. So you don't have to do like annoying either finding them manually or Control F or anything like that. Okay, try and get distance. Now, let's see, is there anything else? All right, reset. Public void reset encoders. Encoder. Encoder.reset. That should be all for encoders. And we're not really going to use it except for with PID controllers and autonomous. And we only have 10 minutes left, so it's not really enough time to get into PID controllers. I guess I could like introduce the idea. We won't really do anything with it. So in that case, we'll, oh right, I guess I should push this and all that, but I'll do that on my own time. For now, so have you ever heard of PID controllers? You have. Okay. So a PID controller is basically, so a PID controller is basically like a way that you can tell a motor to go to and maintain a certain value. And it's a way for it to like start approximating it and like zero in on that value in a nice and smooth way. I don't know how much I should explain this, because have either of you taken calculus?
Not really.
Yeah. Okay, well, then basically, that's fine, because you absolutely don't expect it. PID stands for proportional, integral, and derivative. So,
Except try my best.
yeah, I mean, I don't know, like,
It still makes sense.
it can still make sense, yeah. So basically, it's three terms that are added together. So it has this error value that is the difference between the desired, so like desired minus actual value to the motor. You'll input its desired, of course, and you'll like hit the absolute value, and it'll have that error. So you'll have like three functions: P of E, I of E, where E is your error, and D of E, and your output is going to be that P value plus your I value plus your D value. And your P of E is going to be this is a very good way to write it. Normally it would be written something like F of E, which is your output, equals equals normally you would have like P as a coefficient, I as a coefficient, and D as a coefficient. So the proportion just times your error plus the plus your I term times the integral of from when it was reset to that time of your E value, and then plus your derivative, your D value. That's not single. Your D value for your time derivative of e. So that way, if you only have a p-value, then it would start you off and multiply it. It would multiply your proportion times your e-value, and it would set that as your power. No, it's not really the absolute value, because if it's a negative error, then it will push you in the positive direction, right? It's to find that value. And because it's like this, if it's just the p-value, it'll basically continuously oscillate around your desired value based on where you start. Because it's multiplied by your error, it's like simple harmonic motion sort of thing. So it's the I value and the v value that cause it to approximate more and more, and eventually get to that desired value. And so we would have to fine tune this p, I, and d in order to get it to work well. So it's a kind of basic explanation. Does that kind of make sense?
Yeah.
Yeah.
Yeah. Generally used for if you're using feed forward in addition to PID.
Yeah, it is. I'm not really sure how that works.
Basically, when you're in, with the Stronghold robot, where you had a flywheel that you were using PID to keep at a constant speed.
Mm-hmm.
When you know the ball is about to come, you can automatically compensate for that beforehand.
Yeah. Okay. Well, so that's an introduction to it. We can implement it in the code next time, along with starting some autonomous code. Yeah. So, that is it for today. Hey guys, thanks for watching. I hope you learned something, and I'll see you in the next one. Hi, I'm Sean Tierney, and this video is the second group's second session of the 2019 Java Workshops Java for Java and FRC Java.
What?
He's doing his, he's recording his intro.
What?
What? What do you want?